Hello, everyone. Welcome to my channel. In previous videos, following the timeline of math development, I talked the history of natural number, fraction, negative number, and zero. Today I will continue to talk the history of rational number. The outline of today's talking topics is ancient beginnings, Indian and Greek contributions, medieval Europe, modern perspective, the end. Numbers have been part of human history since the very beginning. As you see the picture, early humans were going to divide objects using counting tools such as bones, sticks, and clay tablets. They used natural numbers, and even fractions to count objects. Actually, fractions are the earliest rational numbers humans used. Then, what is the rational number? A rational number is any number that can be written as a fraction of two integer numbers, denominator p over the denominator q, but the denominator q cannot be 0. Examples include 1 over 8 and minus 7 over 1. The set of all rational numbers, denoted by a big capital letter Q, is closed under addition, subtraction, multiplication, and division, except by 0, forming the field of rational numbers. Civilizations like Egyptians, Babylonians, Indians, and Chinese used rational numbers to divide food, land, time, and money. For example, 1 over 2, 1 over 4, 7 over 8. The Rhind mathematical papyrus, Egypt, 1650 BC, contains dozens of examples of fractions. As early as 300 BC, Greek mathematicians, like Euclid, defined ratios in terms of geometric magnitudes. When lengths are commensurable, the defined ratios can be considered rational numbers. Then, around the 5th to 7th century CE, Indian mathematicians used fractions in astronomy and algebra. Through translations of Arabic mathematical texts, rational numbers reached Europe. Fibonacci's book, called Liber Abaci, written in 1202, helped fractions become widely used for commerce, especially for currency and trade. Today, it is widely known that rational numbers are those whose decimal expansion either terminates after a finite number of digits. For example, 1 over 8 equals 0.125. Or eventually begins to repeat the same finite sequence of digits, over and over. For example, 2 over 3 equals 0.6666 and forever. The rational numbers form a dense set. Between any two rational numbers, there is always another rational number. They are fundamental in arithmetic, algebra, and number theory. The concept of rational numbers is very old, but its formal discovery is intertwined with the discovery of irrational numbers. Next, I will talk the history of irrational numbers. Okay, it is time to end. Don't forget to like and subscribe. See you next time.